So in this video we want to briefly discuss multiplicative identity matrices. So when we looked at our properties of matrix operations, we identified that there existed a multiplicative identity and we named it I. And the identity exists such that A times I equals I times A equals A. So this identity matrix plays the role of the number 1 in the real numbers under multiplication. And so we want to talk a little bit about what I looks like. So the identity matrix for multiplication is always going to be a square matrix. It's always going to be a diagonal matrix. So remember, a diagonal matrix has zeros on all element positions except the main diagonal. So it's going to be a diagonal matrix with ones on the main diagonal. So for example, if I have a 3 by 2 matrix, an arbitrary 3 by 2 matrix, let's say the matrix A, B, C, D, E, F, the identity matrix, the multiplicative identity matrix for this 3 by 2 matrix is going to be the square 2 by 2 matrix. It has to be a 2 because these numbers need to match in order for a product to exist. We need the same number of rows as we have columns for the dot products to exist. So the identity matrix, the 2 by 2 identity matrix, which I would denote I sub 2, would look like this. It would be a diagonal matrix. So zeros in every position except on the main diagonal, and the main diagonal will be all ones. So this would be the 2 by 2 identity matrix. So identity matrices will always be square matrices. And so if we multiply this out, what we'll see is multiplying by this matrix preserves the identity of the original matrix. So if we multiply first row, first column, we take the dot product of the first row and the first column. We get A times 1 is A plus B times 0 is A times 1 plus B times 0 is A. Row 1, column 2. So the row 1, column 2 position. Remember, this needs to be a 3 by 2 matrix here, because when you take a product, you get the first number by the last number is what the result will look like. So 3 by 2 times 2 by 2 will yield a 3 by 2 result. And we'll get in row 1, column 2, we take the dot product of row 1 and column 2. So we'll get A times 0 plus B times 1 equals B. And we get, for this next spot, we get row 2, column 1. So the dot product of row 2 with column 1 would be C times 1 plus D times 0 is C. Row 2, column 2, C times 0 plus D times 1 is D. Now I'm in row 3, column 1. So row 3, column 1, the dot product of the row vector with the column vector, it's E times 1 plus F times 0 is E. And E times 0 plus F times 1 is F. So we can see that multiplying by this 2 by 2 identity matrix preserved the identity of the original matrix under multiplication. So in general, any M by 2 matrix, this matrix here, the I2 matrix, will be the identity matrix under multiplication for any M by 2 matrix. If we have an M by 3 matrix, then we need I3. We need the identity matrix that is the 3 by 3 diagonal matrix that has all ones on the main diagonal and zeros in every other position. So if we have an M by N matrix, then the identity matrix is going to be the I sub N identity matrix. The N by N square matrix that is a diagonal matrix with ones on the main diagonal. So that's how you construct your multiplicative identities. You look at the number of columns in the matrix you are interested in multiplying. You construct the N by N a diagonal matrix with ones on the main diagonal to create the identity matrix. multiplicative identity matrix.